For example 4, I'd actually like you to do this one on your own. So please pause the video and then replay it so that you can see what the answer should be and what your solution should look like. So Lipit, I think by now you've got that. Logs, yes, we have log. Okay, dx always goes there, but look, there's nothing else. So we know that the derivative of ln of x is 1 over x dx. We know the antiderivative of dx is just x, right? Okay, and so we do our same thing. Okay, ultraviolet, so u times v is x times ln of x minus the integral of, again, v du. Okay, so we have x times 1 over x, well that's just 1 dx, so we get x times ln of x minus x plus c. And that's it. Alright, very nice. I wanted to point out a couple key things that students do that really drives them crazy. You know, there's some things that you can do that will make your life more difficult, and if you don't follow what I've been telling you to do, then you're gonna run into some trouble. So this is what I mean. If you wanted to integrate this function here, and you're not remembering Lipit, you might think, oh, okay, well let's let u equal e to the x, and that's an exponential function coming before a polynomial. Remember, Lipit means what do you let u equal? Well, if the polynomial is in there and there's also an exponential, do not let u equal the exponential function. Let me show you what happens. See, I don't want you to do all the work. Maybe just take a look at it. We've got, you do all the work here, you've got ultraviolet, voodoo, and you end up taking x e to the x, which is the integrand, and turning it into another integrand, which is actually more complicated than the original one, and so that's not what we want. We're using integration to trade one integral for another. And here it says, if you just read this, the bargain is worth making only if the second expression is easier to integrate. Well, we didn't get something that's easier to integrate here. So as soon as you get something that's not as easy to integrate as the one before, or if you don't get something that's easier, then you did something wrong. And so immediately stop and go back and see if you maybe chose the wrong u. Okay? So the other mistake that's common that students make is, let's just say you're in a section where you're not really sure, like on a test, where it doesn't say use integration by parts to evaluate this or to find the antiderivative, and you go, oh well, I'm just so used to parts now, I'm going to use parts for this, and you try e to the x squared, and that doesn't work because you get something bigger nightmare here, and then you try u equals 2x, because that's a polynomial. You go, okay, polynomials first, that's polynomial there. And then you get over here, and you have to find an antiderivative for the e to the x squared, and you're like, wait a second, I don't have an antiderivative for that. So you're stuck in the abyss here, but the issue here is that integration by parts is not what you should be using to find the antiderivative. You should just do a u substitution where u is equal to x squared and du is equal to 2x dx, and then it becomes a really simple antiderivative. Okay, so please just be careful with that. When you're not told exactly what kind of method to use, then be careful. Okay, always try u sub first. All right. Now, it doesn't mention in this, in this set of worksheets here, the Lipit part, but that, like I said, that has never failed me, so just stick with that and you'll be fine. I want to do 2 more examples, actually 3 more, where number 5, I challenge you to do this one on your own. I think if you don't remember the derivative of the arctangent, then you're in trouble here. But Lipit, remember, logs and then inverse trig. Well, guess what? Inverse trig is what we have here, arctan. I don't like to write it as arctan. I want to write it as inverse tangent of x. Okay, that's my u. My dx always goes with my dv, and we don't have anything else, so that's what it's going to remain as, just dx there. Now, the derivative of inverse tangent of x, so it's critical in this section, in fact for the rest of your life, that you remember all those derivative formulas, okay? So the derivative of the inverse tangent of x is 1 over 1 plus x squared dx, and the antiderivative of dx is just x, okay? So we just rewrite this, u times v, so ultraviolet voodoo, okay? So we're going to write that as, I'll start over here in case we run out of room, x times inverse tangent of x minus the integral of x times 1 over 1 plus x squared, so x over 1 plus x squared dx. So this is kind of a neat thing because I really like this. Not only do you have to use the integration by parts, okay, to get this far, but you should recognize this integrand here as an integrand that we're going to use u sub. That's right, we're going to use u sub. So we let u equal 1 plus x squared. We know that du is equal to 2x dx. And we really have very little room here to do this. However, we're going to give it a shot. 1/2 du is equal to x dx. So guess what? We've got that x dx right there. And the x dx is the 1/2 du. So this is a little review of u sub. Yeah, we get to do parts and u sub in the same problem. Alright, and then we have 1 plus x squared. And that is our u, and it's just one big party. Okay, let's see if we can leapfrog this stuff right here. We're going to take this guy right here. I know this is getting really, gosh, it's really complicated here because it's getting all crammed in. Not enough room here. My apologies for that. Alright, so let's write our x, tangent inverse tangent of x minus. Okay, so let's recap what we did. We have a 1/2, we have 1 over u, and we have a du. Okay, so I didn't let you see that very well, did I? But that's what we have so far. And so we rewrite our x inverse tangent x minus 1/2, and we know the antiderivative of 1 over u is ln of absolute value of u plus c, and now all we have to do is put that u back in, and the u is 1 plus x squared, and guess what? 1 plus x squared can never be 0, and it can never be negative, so we don't need the bars. Plus c. How awesome a problem is that? Oh my gosh, that is a great problem. It would be even better if you had a lot of room to do that problem. But there you go. These last couple examples are critical because you're gonna, you see something a little bit different here. Parts and u sub in the same problem makes it great. This one right here, repeated integration by parts. Let's take a look at that. See if we can get these last two in here in this video. And I might, I think I will. I'll just do this one and then we'll do the other one in class. Okay. It's just another, kind of like a special case. These are like this one here is a special case, and so is example 7. So we'll do example 7 back in class, and then we'll do those tougher ones as well, possibly. But anyway, let's do this one. We've got, we know again, I'll just keep writing this. I encourage you to do the same thing. It just is a good reminder, the lipit. We know we have no logs, no inverse trig, but we do have a polynomial, x squared. And then our dv then would be our e to the x dx. And that's an easy one. We like their e to the x. So we have e to the x there, and we have 2x dx here for the derivative of x squared. Okay, well, again, we do our ultraviolet voodoo. I hate this thing. It's not your problem. So ultraviolet voodoo, so we got that and that, u times v, and we get u times v is x squared e to the x minus v du. Integral of v du. So we have 2, I'll put the 2 out front, x e to the x, okay, and dx. Don't forget about that. Well, we're a little bit better. We're not 100% better, but we are a little bit better than we were the time before. So guess what? You knew that this was the section of repeated integration by parts, and that's in fact exactly what we need to do. We can't do a u sub here because we don't have a function and its derivative within the integrand. Okay, so coming on down here, what should we do? Alright, so we get u equals, and then v equals. Yeah, you have to actually write down your own little chart. Making you do a lot here. Yeah, you got to do your own chart sometimes. In fact, the rest of your life you have to do your own chart. You're not going to be provided with that anymore. Alright, u equals, again, we follow Lippitt, and we've got, now this one, x is our polynomial. Our dv is our e to the x dx. Okay. And then we know that du is equal to dx, and we know that the antiderivative of e to the x is e to the x. We do our ultraviolet voodoo one more time, and we've got, maybe we'll go right down here. We go equals, yeah, equals x squared e to the x minus 2 times this now. Okay, so this right here, all this stuff here, ultraviolet voodoo, is the antiderivative of everything here. Okay, 2 times what? What's the deal? uv, so u times v is x e to the x minus the integral of e to the x dx. We can do that. Okay, we get x squared e to the x minus 2x e to the x. Okay, now be careful. A minus here and a minus here is a plus. Okay, and we have to distribute the 2. 2 times e to the x, and we have plus c. Isn't that a pleasant one? No, these are, I understand they are challenging, especially in the beginning when you're getting used to this stuff. But anyway, there you go. That's really, in a nutshell, that's the integration by parts method, and I will see you in class.